I also think that laziness applies in the operations role to our choice of tools. There's a whole crop of new or new-ish tools that are starting to be used in web development that are kind of different from the previous set of tools that we're used to using. And in particular, we have all these tools sort of embracing this concept of eventually consistent. Right? A traditional database is immediately consistent. You say insert, and as soon as the database says OK, that data is available to read. You don't have to worry about whether that data has actually hit the disk yet. If the database tells you it's there, it's there. But there's this whole new crop of tools, usually called NoSQL, that sort of embrace this concept of, all right, you've written some data, I'll commit it eventually. And all of a sudden, as an application developer, these tools are great, right, because they let us scale at a whole different level, and they let us be lazy about our consumption of resources. But they do mean that as a developer, we have to start thinking about concepts like fsyncs and when the data actually hits the disk. And we have to start allowing for deployment concerns, understanding of the low levels of what our tools are doing in our application itself, rather than just letting the database worry about consistency. Consistency all of a sudden becomes an application level concern. So DevOps, right? You have an operations concern being pushed down into the application level because it allows us to achieve greater scale. I'm not really going to talk about NoSQL because that would take a long time, and it would kind of turn into a rant towards the end, I think. But I kind of think this whole NoSQL thing is something of a fad. I'm just going to say that. It's controversial. Find me later and we'll argue. What I don't think is a fad are queues. I think queuing is one of the best new concepts to hit web development. And again, queues aren't particularly new, right? None of this stuff is I'm not arguing that we web developers have discovered this whole new paradigm. But what we have done is started to understand that these types of concepts are really important to our job as web developers. And in particular, the ability to spin off some work to be done later is incredibly important to a web developer. Web developers are used to thinking in incredibly small time slices. We're used to thinking in, the 10 milliseconds between a request and a response. And we know that we've got this very, very small time budget. Some websites, Amazon.com is one, is actually explicit about this. Amazon's web presence is composed of a whole bunch of different web services. When you request a page, behind the scene, Amazon is making a whole bunch of internal web service requests. And each of those individual pieces has a particular time budget allotted to it. And if you exceed your time budget for that subcomponent, your subcomponent isn't rendered. Right? The page that's being rendered just gives up and goes away. It's a concept I've seen applied in other places, but Amazon does it sort of the most brutally. If you're responsible for the Kindle book recommendations widget on the home page, if you can't get it done in your allocated amount of time, your bit doesn't get shown, right? That's pretty brutal. Queues are pretty much the only thing that let web developers break out of this request-response cycle. It lets us say, we've got this much more complicated bit of code, run it later. Again, we're seeing an operations concern, time and performance, being pushed back down into the application. Right? We don't have the luxury of saying, hey, sysop, this thing is slow, make it fast. Give me some more hardware. Because we've actually reached limits on what we can do with just make it fast. So we have to push that concern down onto the developer themselves. A great queue tool, if you're not using one, is Celery. Celery started out as a Django-only tool, but it's been mercilessly refactored to the point where it works with any Python tool, web or not. And it's got plugins for a number of popular web frameworks, Django, Pylons, Flask. I'm sure there's a few other plugins to sort of integrate it with other frameworks. Celery is not the fastest queue. It's not the most scalable. It's not the, it's the 80% solution. It's going to work for the majority of people most of the time. And it's incredibly easy to use, and it'll get you thinking about about queuing as a concept. I particularly like Celery because, again, most of us are not Google. Most of us do not have millions of tasks in our queue. Most of us have, dozens or hundreds maybe. And Celery is perfectly adequate to handle that sort of a thing. And once you're using one queue, it tends to be reasonably easy to refactor and use a different one later on. You've already separated your work into you've already done the architectural task of figuring out which units can be split. So switching the actual tool you're using, easy enough. Here's just a quick example of how a Celery task looks. And it's you just write a Python function like any other Python function, and you decorate it with Celery's task decorator. And that turns it into a unit of work that can be spun off into a queued job. And then later on, somewhere in your code, instead of calling that function directly, you call function.delay and pass in the arguments. That's it. Just instead of calling it, you call .delay and give it the arguments, and Celery takes care of it. You can have multiple Celery worker processes on the same machine or spread across multiple machines, or it can just be on one single machine. You're pretty flexible about how you spin that work out. So it's really, really easy to, as you're doing some work and you realize that this chunk of code is going to be slow and can't be done in practice, you just refactor it out into another function, wrap a decorator around it, convert the calling function, instead of calling it, call .delay, and you're done. It's very, very quick. Like I said, the architectural work is the more complicated part, figuring out how to deal with the fact that you're going to tell the user, OK, that's done. In fact, you're actually doing it in the background. And my little contrived example here just sort of shows off that you do anything you could in a normal Python function. Here I'm using Django's ORM, and presumably I'm using the Celery Django connector to make sure that works. But whatever you want to do in this function is fair game. So when Ed says that we're all ops people now, I interpret that to mean that we're all already ops people. We've all already figured this stuff out. The tools that we need to use this, are details we need to learn, but we're good at that. We're good at learning new tools and new languages. Most people, I love it. I love learning new things. Most developers do. The concepts, the basic ideas, they've been with us all along. So impatience. So Larry describes impatience as essentially when the computer doesn't work for you, when it doesn't do something you think it ought to do correctly. In other words, we're allowed to be lazy, right? We're people. We get to be lazy. But developers, but computers, not so much. They're not allowed to be lazy. I want to ask you, how long does it take to deploy your website? Can you do it in 10 minutes? Can you push out and deploy in 10 minutes? 5? Can anyone do it in 30 seconds? Yeah. How about provisioning a new server? Can you do that in a day? Whatever you're using. Can you do it in a day? Can you do it in a minute? How about to test out a brand new major rollout? Do you even test out huge new rollouts? Dig doesn't. Ask them how that worked. Why are we willing to wait? At a lot of companies, provisioning a new server can take weeks. Why are we waiting for that? New deployments can take hours. Why do we put up with that? Why do we wait? Impatience tells us we should be able to do any of these things as quickly as possible. It's just software. Computers should be able to do this quickly. We shouldn't be content with explanations for why these things have to be slow. And of course, as you led me into, virtualization and the cloud sort of is a solution to most of these problems. Again, cloud computing, a lot of hype, a lot of people trying to sell you something. But the underlying idea that you can treat a machine as an API that you can spin up a new machine in 10 seconds and have access to it immediately and pay by the hour or by the minute for that machine is just an absolutely incredible change. It means that developers can treat hardware the same way we treat any other API. We get access to booting machines as a developer concern. How cool is that? That's amazing. This is what it takes for me to spin up and provision a new machine in one of my clusters. I'd use an API call here. I'm using Rackspace Cloud, but I could be using Amazon or whatever. I boot a new machine, and I provision it, and I'm done. It takes elapsed time, 3 minutes maybe. Most of that's spent waiting for the machine to boot. If Ubuntu would boot quicker, it would probably be down to a minute. That's fantastic. That means that if I start seeing loads spike up, I can boot a new machine immediately to take care of it. To be a good DevOps engineer, I think you have to have a virtualization strategy. This could be a hosted stack like Amazon or Rackspace or what have you, or it could be something local like VMware or Eucalyptus, which is an open source clone of EC2. You could be using libvirt. I mean, there's just all sorts of options for this. I don't think that it particularly matters what you're using, but what matters is that developers get to decide when new machines get brought online. Developers get to control that from software. You don't have to call IT, place an order from Dell, wait while they ship it out to you. None of that. And the things that you can do once you really embrace virtualization, once you have developer access to running machines, is just really fantastic. I mean, what about self-scaling infrastructure? I had the idea once, working on a news site, and every time we showed up on Dig, we'd go down because we didn't really have the budget to optimize for that ridiculously huge spike. We couldn't, 99% of the time we weren't getting that level of traffic. So why not write a web scraper that watches the front pages of all the sort of social news sites, and as soon as you see an article from your site on there, start spinning up some new machines. That's great. Or monitor the load across your stack and bring up new machines as needed. Or if you're using a queue, monitor your backlog. And if your backlog gets beyond a certain point, bring up new workers to work on it and shut it down when you're done. Cloud people tend to focus on the ease of booting as the important part, but I actually think the ease of destruction is the more important part. Once you've ordered that server from Dell, it's bought and paid for. You can't send it back if it turns out you don't need it. But if you boot a new machine in a cloud environment and you don't need it, you can just kill it off real easily. Type